Hello, dear students. Welcome to the channel and very welcome to this playlist in which we are discussing about 8051 microcontroller in detail. So, up till now, we have discussed a lot about microcontroller in general. We have discussed pin diagram, block diagram. We have seen memory organization of it. We have seen timers, counters, serial input output ports, input output ports, interrupts. We have seen almost everything that is related to the theory parts. So, if you remember, we have discussed about addressing modes in 8085 processor microprocessor as well earlier. And in similar manner, today we are going to discuss about the addressing modes of 8051 in detail. So, if you want to check out the video related to the addressing modes in 8085, the link will be flashing on the top right hand side corner of your screen. You can click on it and you can reach there. Except that, also if you want to check out the playlist in which we have discussed about 8051 in detail, so the link of that playlist will be flashing in the I button as well on top right hand side corner of your screen right now, so you can go there and check out that. And I recommend you check out the playlist because in order to understand this today's class, the understanding of that video is helpful. But even though if you don't have it, it's okay, you can still understand today's class. So without further ado, let's get on today's class. So we all are pretty much familiar about addressing modes. Okay, addressing modes in any microprocessor or any microcontroller. So addressing modes in 8051 is not very much different from addressing modes in 8085, because when a microcontroller executes an instruction, it performs specific function on data, and the data is stored at some source location, and that data must be moved or copied to the destination location. So the way by which these address locations are specified are called addressing mode. Okay, so remember what was the definition in microcontroller? It was same. Instead of microprocessor, so definition of addressing modes was same, except the term microcontroller we used to use microprocessor. So it is all same. And see here we have six total in total six addressing modes for microcontroller 8051 here, starting from direct addressing mode, then we have indirect addressing mode, register addressing mode, register specific addressing mode, immediate addressing mode, and finally index addressing mode. Now let's try to find out about each and every one in detail. So first one is the direct addressing mode. In direct addressing mode, what happens? The operand is specified by 8-bit address fields in instruction, and once one can access all 128 bytes of the internal RAM and SFRs directly. So using the single byte address that is assigned to each RAM, uh, using this single byte address that is assigned to each RAM location and each SFR. SFR stands for special function register, by the way, if you don't know. We have covered that part in the playlist as well, so you can check out the playlist. So the most significant bit, or MSB in the address, decide whether the location is within on chip or within on chip internal RAM or not. So if this MSB or most significant bit is 0, then the location within the within on chip internal RAM, and if MSB would be 1, then the location is in the special function register. Okay, so simply if MSB is 0, then location would be on chip internal RAM. If MSB is 1, then location would be in special function register. So now the internal RAM uses addresses from 00H to 7FH to address each byte. So SFR addresses are from 80H to FFH, And about that we have discussed how SFR registers memory, how memory organization takes place in SFR as well, so you might remember that. Now what is the example of direct addressing mode? So it is like move a comma 40h is basically example of direct addressing mode. We are going to discuss about instruction about each and every addressing mode in detail in upcoming classes, but for now just understand that move a comma 40h would be the example for direct addressing mode. It copies data from address 40h into the register directly, right? So it is direct addressing mode. Similarly, if you want to do the same thing rather than register A, which means accumulator, you can do it. Let's say move R0 comma 14h. So what would it do? So it would copy the content of the memory location 14h to the register R0 of the selected bank. So after direct addressing mode, we have the indirect addressing mode. So what do we do in indirect addressing mode is that the instruction which specifies a register which contains address of operand. What do we do in this addressing mode? The instruction specifies the register which contains address of an operand, like register holds the actual address which is used in the data move, right? So this address may be of 16-bit or 8-bit, and R0 and R1 of each register bank can be used as an index or pointer register. So R0 and R1 point to the contents in the RAM, and if address is 16-bit, then we use data pointer. Okay, so not only in this case, but every single time we go for a 16-bit address, we use data pointer. So mnemonic symbol that is used for indirect addressing is the sign at the rate. So if you want to go for indirect addressing, what are you going to use? You are going to use at the rate. So for an example, move a comma at the rate 20, a comma at the rate r1. So what would it do? So it would copy the content of the memory location whose address is specified in r1 register. Okay, not the content of r1, the content of memory location whose address is specified in r1 of selected bank to my accumulator, right? So what we are doing here, we are indicating that register to act as a pointer, right? For example, let's take another one, move at the rate r0 comma 85h. What would it do? So it would copy the data address of 85h to the memory location whose address is specified by the r0 register of whatever bank is selected. So here you are using at the rate to indicate the register as a pointer. So here what did we do? Only register R0 and R1 we can use for indirect registering register addressing. If R0 to R7 are used, then the microcontroller will give you signal saying invalid instruction. Okay, so you can only use R0 and R1 registers for indirect addressing, and we are going to see that in detail as well in upcoming class. For now, let's see the register addressing mode. So in register addressing mode, what do you think? What is your understanding would take place? So understand this. Each register bank consists of register R0 to R7, right? And to access these registers, there are specific instructions which we call special instructions. So in this instruction, opcode 3 bits. In this instruction opcode, 3 bits are reserved for specifying one of the write registers from the selected register bank. And for selecting the register bank, the user has to modify 2 bits into the PSW. Okay, so see the example. It would be move a comma r2. So what would it do? So it would copy the data from register r2 of the selected register bank of register a, right? So it is not as complicated as indirect registering mode. It is directly copying the data from register r2 to my selected register bank to register a. Then we have advanced one, register specific address mode. So what will happen in this addressing mode? The instruction refer to specific register like an accumulator or data pointer, right? So it's simple. Let's say swap A. So when you write swap A, then it will swap the nibble with the accumulator. When you write DAA, so what it would do, it would decimal adjust accumulator for addition. So this register mode is not used very commonly, and the instruction sets of these registers are pretty much indicate that you are using this addressing mode. Not register, sorry, addressing mode indicates itself that you are using this register specific addressing mode. Then we have the immediate addressing mode. So in immediate addressing mode, what would happen? In this method, uh, we are going to get the data just like other methods, but this one is the simplest. So in this addressing mode, the source operand is a constant rather than a variable. Okay, so as the data source is the part of the instruction, it is immediately available, and for that the for the mnemonic will use the immediate data, and it's indicated by the sign hashtag. Okay, so when I write move a comma hashtag 30, it would immediately copy 30h to accumulator. If I write move p1 comma hashtag ffh, then it would copy ffh immediately to port 1, right? If I write dptr comma 1234h, then it would immediately copy 1234h to my data pointer. Understood? So this is immediate addressing mode, and this is simplest one, so it's very simple. You don't have to do anything. After that we have indexed addressing mode. So in the indexed addressing mode, only the program memory can be accessed, and the program memory can be read. So this addressing mode is preferred for reading lookup tables in the program memory. Either the data pointer or program counter can be used as an index register. And in jump instruction as well, this addressing mode will be very useful. Okay, whenever you want to execute the jump instruction, this is going to be useful the most. For an example, if I have an instruction move c a comma at the rate a plus dptr, so it pretty much a long instruction. We will see the instruction in detail in upcoming classes, so don't worry about it. But for now, just understand that this instruction will load the accumulator with the byte from program memory, right? This instruction will load the accumulator with the byte from program memory, and the byte from program memory is fetched from the sum of unsigned 8-bit accumulator contents and content of the data pointer, right? Now let's see the instruction set of 8051. So see, this much are these are the instruction sets of 8051. So these instructions treat different type of operands uniformly. The register, memory, and immediate operands may be specified interchangeably in most of the instructions. And this instruction set is basically divided into the number of group of functions related instructions. Okay, so here I have mentioned 5 total groups in which we have divided number of group, we have divided the functionally related instructions. So first one would be data transfer group, second one would be arithmetic group, third one will be the bit manipulation group, fourth one the program transfer instruction group, and fifth and last one would be the processor control group. Let's see each and every one of them in detail one by one. So the first we have is the data transfer instruction group. In this, Let's first understand instructions one by one. First, let's take move instruction for an example. Here we have the move instruction. Let's say move a comma rn, or move on the left hand side you will write destination byte, and on the right hand side you will write your scr byte or source byte. Okay, so that is the mnemonic. So this mnemonic for this is move a comma rn, or move destination byte comma source byte. What function does it performs? So it moves the byte variable, like it moves the byte from register to accumulator. See, on the right hand side you have source, on the left hand side you have destination, so it would move from register to accumulator. And what would be the algorithm? So the data in the register would be equal to the data in the accumulator. It would be rewritten, and the operation is going from source to the destination. So basically, instruction copies the content of the source location to the destination location, and the content of the source location remains unchanged. I'm repeating one more time. Even though you may have seen this one in the previous instruction set of 8085, but let me repeat it one more time. The instruction copies the content of the source location to the destination location. So the content of the source location remains unchanged, and it's the most flexible operation, allows 15 combination of source and destination addressing modes, and depending on the type of transfer of the number of bytes which are required, it can be 1 or 2 or 3, and the number of cycles required can be again either one cycle only or two cycles max to max. So let's see the different combinations of this move cycle. And the first one you are seeing on the screen itself here is move a comma rn. You've already seen the mnemonic function algorithm operation. So let's move from there to how many bytes it contains and what function it performs. So instruction copies the content of register rn to accumulator. It contains only single byte, requires two clock cycles, and it is a register addressing mode. So uh, what flags does it actives? So no flag is affected here, and no other register except the source and destination registers are affected either. So what will this instruction do? This instruction will copy the content of register R1 on the selected register bank to the accumulator. Okay, and how? So see, before execution, accumulator, what does accumulator have? Accumulator has 4T. Okay, and what does register R1 has? So before execution, register R1 has A0. Now you execute move a comma rn, and at the end of this instruction what will you get? The accumulator will have the content of the register r1 of the bank 0, which means the accumulator will also have a0 in it, and the content of the register, remember, content of the register remains unchanged. So the value of the data in the r1 will still be a0. It will not changed. It will not be changed. Okay, now let's see another one. So this instruction is a move a comma direct, which what function does it performs? It moves the byte from direct address to accumulator, and in algorithm the uh, data into the direct address will directly copy to accumulator. So except these two addresses, other addresses are not affected, and the data will remain same. There will be no change in the data. We are not performing any arithmetic expression here till now. And this instruction will copy the content of the direct address given by the instruction to the accumulator. Okay, instruction will copy the content of direct address given in the instruction to accumulator. So how many bytes does it hold? 2 bytes again, just a single clock cycle. Again, it is a direct addressing mode. Previously also register addressing mode is also part of see how many addressing modes did we saw? Sorry, here 6. So register addressing mode is also part of addressing modes in 8051, and direct addressing mode is also part of addressing modes in 8051. So keep in mind which addressing mode we are using each and every single time. Okay, so this is direct addressing mode because we are directly transferring from some address. We are not taking any register in operation, right, except the accumulator, but we are moving to accumulator. So this is direct addressing mode, and in the process no other register or flag is affected except the accumulator in and whatever memory address. Let's say we are having 40h, so the instruction will copy the content from memory location whose address is 40h to the accumulator. Okay, it will not copy 40h to accumulator, it will copy the content of the memory location 40h to accumulator, right? So before instruction, see, this is the memory location 40h. What data does it have? It has 10. Okay, and accumulator, what does accumulator have? Accumulator have 40. Okay, so after instruction, the content of the memory location, okay, so this 10 will be transferred to accumulator. So accumulator will also have 10, and this remains unchanged. Okay, so there will be no change in the content of the memory location of 40h, right? So pretty simple, understandable. Now let's move to the third one. So this is again, this is a move a comma at that ri. I might have forgotten to mention that on in the slide, but it's okay. Okay, it's a move a comma at the rate ri. So tell me which addressing mode will it have? A comma at the rate ri. See, ri is taking place here. At the rate is taking place here, and the function it will perform will be the it will move the content from memory location to accumulator, right? So what will be the algorithm? A equal to into the double bracket ri. What does it mean? We will see. We will see whenever we discuss every instruction in detail. So this instruction will copy the content of the memory location. I'm repeating one more time. Instruction will copy the content of memory location whose address is specified in the register ri. Okay, it will copy the content of memory location whose address is specified in the register ri of selected bank of the accumulator. Okay, so and I will make you understand by example as well. It is only single byte instruction and includes only one cycle, and always remember we got at the rate and ri. So this is register indirect addressing mode. Okay, at the rate stands for indirect, and we are involving registers in it, so it is register indirect addressing mode, and no other register or flags is affected here. Okay, so this instruction will copy the content of the memory location whose address is specified in the R0 register of the selected bank to accumulator. I'm repeating, instruction will copy the content of memory location whose address is specified in the R0 register of the selected bank to accumulator. Okay, so let's say R0 is 40h, and the content of the memory location that you can see, in memory location 40h, what is stored? So 10h. Okay, it is showing 10h. So whatever the content of the memory location whose address is pointed by the register, which means 40h are copied to the accumulator. Okay, you already had 40h before the execution. You already had 40 before the execution. Now 40h holds 10 inside the uh, inside of it. So what will happen? The data in memory location 10h will be copied to accumulator. Okay, so that would be 10. So 10 would be copied. Okay, so and after execution the 10h will remain as it is in 40. Now let's see the next instruction, because we have seen already move. We have seen three examples of move. Let's see move x. So this one is the move x, which stands for move external. Okay, move x stands for move external. Again, on the left hand side you will have destination byte, on the right hand side you will have source byte. Algorithm is again the content of the destination byte and source byte uh, will remain same, and MOVEX instruction will transfer the data between accumulator and byte of external data memory, right? Byte of external data memory, that is why we are adding this x after move. And depending on whether the indirect address provided to the external data RAM is 8-bit or 16-bit, there are two types of instruction. In the first type, content of register R0 and R1 of current register bank provide 8-bit address that is multiplexed with the data on the port 0, and 8 bits are sufficient for external input output decoding expression decoding, or for relatively small RAM array. In second type, the data pointer is used for generating 16-bit address, which is done for a larger RAM array, and port 2 outputs the high order address bit, or the which would be the content of DPH, while the port 0 output the lower address bits, right, content of DPL. Okay, DPH and DPL will be data pointer higher order address and data pointer lower order address multiplexed with the data. So this instruction will again hold only single byte, will take 2 clock cycles in total, and again tell me what would be the register, what would be the addressing mode. It would be the register in addressing mode. Okay, but register indirect addressing mode, because we are having at the rate here. Again, no flags are affected here. Now let's see the instruction in detail. So instruction will copy the data from 8-bit address point by register RI of the selected register bank to accumulator. Okay, so the instruction will copy the data from 8-bit address pointed by RI of the selected register bank to accumulator. Okay, so what does the register bank points here? See, 40. So what will it do? It will copy the content in the 40. What is the content in the 40? It holds 10. What does accumulator holds prior execution? It holds 40. But uh, the register R0 holds 40h memory location. Okay, and what data is stored at 40h memory location? It's 10h stored here. So it will copy the 10 to my accumulator. So we are having 10 into the accumulator after execution, and the content of the source register will remain unchanged. So 40h will still have 10 and R0 will still have 40. Okay, there will be no change in it. Simple enough. Now let's see next one. Okay, in this one also I have forgot to mention the name of the instruction. It is MOVX A comma DPTR. MOVX A comma DPTR. So this instruction will copy the content of the external memory location, which is pointed by data pointer to the accumulator. Remember, we saw two cases. So this is the second one. So instruction will copy the content of the external data memory location pointed by data pointer to accumulator. Okay, so DPH and DPL, see what does it hold? DPH holds 1 0, DPL holds 0 0, and before execution at 1000, what is the data it holds? It holds 22, and before execution, accumulator will hold accumulator holds 08. Now the content of the accumulator are copied to memory location 1000. Okay, why 1000? Because see, DPH is 10, DPL is 00, so 1000 would be 1000. So see, before it had 22, now it will have 08. What was prior execution? Stored in accumulator. So now 08 is stored in the memory location 100H. Again, simple one. Okay, and after execution of the uh, instruction, the content of accumulator is remain unchanged. See, there is no change in the content of accumulator. Okay, now let's see the next one. Move x comma ri, sorry, move x at the rate ri comma a is the next one. So this instruction will copy the content of the accumulator to external data memory location. Okay, content of accumulator to external data memory location, which is pointed by ri of selected register bank. Okay, so see, before execution, the register R0 is containing 40, accumulator is containing 40, and at memory location 40H we have 10. So the content of the accumulator are copied to the memory location whose address is pointed by register R0. So what address is pointed by R0? 40. What value does the accumulator has? 40. So in 40H, the 40 of accumulator will be copied. So now 40 is copied at memory location, and after execution the content of accumulator will remain as it is. Okay, so content of accumulator 40 is remain as it is before and after the execution, as you can see. So we will, I think, keep today's class till here. The lecture has been dragged down long enough. So let's keep today's class till here. If you have any doubts, queries or questions related to today's class, please mention them in the comment section below. I will try to answer them as soon as possible, as many as them possible. If you have any doubts, please mention. Don't be shy. Any feedbacks related to the channel or content is welcome, whether it is positive or negative. And if you have any suggestions for me, if you want me to make videos or shorts on a certain topic, please mention that in the comment section below as well. I will make videos on them as well. So I will be seeing you next time with next data with next transfer instruction set. Till then, thank you very much for listening, and goodbye for now.